So let me get a quick feel for the audience. How many of you are using Windows Server? Okay, good, good, good. How many of you participate in DevOps or go to DevOps conferences? Okay, great, great, great. Okay, so today I'm going to talk about the DevOpsification of Windows Server. I'm quite optimistic about DevOps, but you'll see, I want to talk about specifically what that means. So I go to a lot of DevOps conferences, and this topic, what is DevOps, seems to dominate the conversation. It's a lot of introspection, navel gazing, like, what is DevOps? And, rarely, in fact, 0 times, I've ever been to one of these conversations and people walk away saying, well, that settles that. That's what DevOps is, okay? So, but the one kind of dominant theme throughout all these conversations is that there's a high degree of concurrence that DevOps is really all about culture and processes, and more specifically, that DevOps is not about tools and technologies. So yes, tools and yes about culture and processes, no about tools and technology. But I assert this is incorrect, right? Because the reality is that tools and technology play a critical role in DevOps. More specifically, tools and technologies can make DevOps easy or hard. Now, it's a statement of fact that DevOps was first and most successfully used on the Linux operating system and not so much on Windows. Windows, people tried to do the same thing, and there was a degree of success, but it was harder, okay? And so what I did was I stepped back and I said, well, why is it hard? What are the issues? And then I architected those issues away in Windows Server 2016. So specifically, as part of the planning for the operating system, the Windows 2016 release, I had a specific design goal to make it be a better operating system to practice DevOps. And I'm going to talk about what that actually entailed. So first, the problem, right? In the past, Windows Server has really been silent about this interface between the developers and operators, right? Sort of this hippie mindset, well, let 1,000 blossoms bloom, good things will happen. And okay, that's great, except 1,000 conflicts also bloomed. Lots of different ways to do things, not a concurrence, not a set of standards and practices that people could do. And so again, Windows Server 2016 resolves that interface between developers and operators, and it really does so for what I believe are 2 emerging models for DevOps. There is the traditional DevOps model, the model we all know, right? Okay, I got developers, they write code, operators put that code onto servers, they maintain it, and then there's a set of practices. Hey, we want to do that in small batches, we want to go quicker, etc. But the operators have, the division of responsibilities between developers and operators is a well-defined model. I assert that containers uses very similar, essentially the same abstract model, but who does what is very different. Okay? A lot of the DevOps steps for a container workflow are now done by the developer in the build labs instead of by the operators in the data centers. And so we designed Windows Server 2016 with both of those in mind. So why are we doing this? And the answer is Windows Server 2016 needs to be cloud competitive. Look, Windows Server 2016, Windows Server is an amazing operating system, incredible success. At its high watermark, over 75% of all the world's servers were running Windows Server. But that was before the dark data centers, the Googles, the Amazons, the Facebooks started using Linux to a high degree. And so now that number's gone down a bit. And indeed, we see a lot of people who are doing cloud applications doing so with Linux. And why is that? And the answer is, at this point in time, or at that point in time, Linux gave them more of the characteristics that they were looking for that helped them be more successful with the cloud than Windows Server did. And so we're going to fix that, right? And I liken this, a lot of people think, oh, no, you're not going to succeed. Well, I would like to remind people back when Microsoft decided that it was going to become a server operating system. Do you remember Windows Windows 95, Windows 98? And when that came out, we said, hey, we're going to be a server operating system. The defining user experience of those operating systems was something we call the blue screen of death. And I think everyone in the industry and myself right there at the forefront said, you are out of your mind. There's no way you're ever going to be a server operating system. Just not going to happen. Forget it. Game over. And yet Microsoft took on that challenge. And again, as I say, at its high point, over 75% of the world's servers were running Windows Server. Okay, so now for the cloud, we're going to do the same thing. We're going to do a fantastic job at the cloud. How are we going to do it? Hard work and code. We're going to do code. Okay, so what does it mean to be cloud competitive? Hey, in the cloud, it's all about COGS, it's all about agility, etc. So we need to be fast, we need to be small, we need to be secure, and we've got to optimize ourselves for these DevOps workflows. So there's actually more to it than this, but today in the time frame I have, I'm going to highlight the key components, right? Componentization, package deployment, configuration, containers, and something we call operational validation testing. So in the componentization, Windows Server 2016 offers 3 different deployment options. First is server and a desktop, SAD, because it makes me sad, okay? This is really the client experience with some server components added to it. It is the deployment option that small businesses will use or remote desktop installations will use. It's the client, okay? Next, we have Server Core. Server Core is for your traditional data center applications, high degree of compatibility, etc. But there's a new deployment option. We call this NanoServer. NanoServer, version 1 of NanoServer, focuses in on 2 scenarios. Number 1 scenario, cloud OS infrastructure. Clustered hypervisor, clustered storage, and some network roles, but primarily clustered, Hyper-V, and storage. The next is focused in on born in the cloud applications, right? So you're going to write a new application, you want it to have a cloud design center, maybe you want to run it in a container. This is what NanoServer is optimized for, those 2 scenarios. Going forward, all of Windows Server will be based upon NanoServer. NanoServer will be the foundation, and everything will just be optional components layered on top, okay? Now, in order to succeed with NanoServer, we learned our lesson from Server Core. We didn't have a particularly good management interface for Server Core, and we weren't very clear about what scenarios it was for. And because it wasn't clear about what scenarios it was for, it was difficult to go harness the right people to do the right task. We fixed that with NanoServer, being very clear about our scenarios and investing heavily in management and remote management. Okay, so one of the things was NanoServer has a new version of .NET called .NET Core. It does essentially, it mirrors the technology I've taken with Windows Server. It starts off as a very small component, and then you bring things in as optional packages. Specifically, PowerShell was based upon the full .NET library, or the full .NET framework. So we needed to refactor PowerShell to work on the smaller .NET, and so we call this PowerShell Core. It is based upon PowerShell version 5. PowerShell version 5. Anybody using PowerShell version 5? Okay, everybody's hand should go up. You gotta stop. If you're using PowerShell, you should stop doing what you're doing, grab PowerShell version 5, and kick the tires. It is an amazing release. So first, we did desired state configuration. Talk more about that. Major emphasis of this release. Security, huge investment. We now support classes. Now, from the very beginning, PowerShell was meant to be that unifying tool between developers and operators. You can go back and look at the Monad Manifesto that I published in 2001, 2002, where I was very explicit about this. In reality, we've largely been focused in on operators. With version 5, there's a big shift and a focus more on the developers. So we support classes, we support Visual Studio integration, we support Visual Studio Code, we do debugging, remote debugging, much more emphasis on the developer experience. And let me be clear, the model here is that PowerShell is going to be the infrastructure, the tool set that allows you to be able to manage from any client, to manage any server, running in any cloud, or on premises using any hypervisor, storage, or networking stack. One infrastructure to manage them all. That's where we're going. Okay. So again, we refactored this to run on .NET Core. It has full language capabilities and compatibility, but the commandlets themselves, the modules that you get from third parties and other teams at Microsoft, those need to be refactored on this .NET Core as well. Next year, .NET will be coming out with a version that allows you to write these .NET commandlets once and have them work in the full desktop CLR or in the .NET Core. So I'm very optimistic about that. But right now, .NET PowerShell and all of its commandlets are there, but some of the third-party commandlets need to be refactored to work on this. We're supporting OpenSSH. So that is OpenSSH, client and server, will be shipping in Windows, client and server. In addition to that, this is not any arm's length integration with OpenSSH. We're taking OpenSSH and we're bringing it into the heart of PowerShell, and OpenSSH will be an optional transport for PowerShell remoting. And we're quite optimistic about that as well. PowerShell is now open source, available in GitHub, and available with an MIT license. Right? So you can grab this code, change it to PowerShell to be Jeffrey Shell, and try and sell it for $1,000. Go with God. You can do that. MIT license is an awesome thing. And we have alpha versions available, again, on Mac OS and Linux. So again, this is such a compelling story. You're now going to have one tool set that your operators and developers can use. So when somebody gets in trouble, they can go to the developer. An operator gets in trouble, they can go to a developer and ask for help. A developer gets in trouble, he can go to an operator and get some help, right? And they'll be able to use any client they want to manage any server they want, running in any cloud, because we got great support. When we launched PowerShell on Linux, my launch partners were VMware and AWS. Since then, Google Cloud is in the process of porting all their stuff to PowerShell. So again, any server running in any cloud or any on-premise using any hypervisor, storage, or networking stack. This is what people have been asking me my entire career. And finally, 35 years later, I get to deliver it to them. Sorry for the wait. Okay, PowerShell version 5, huge security improvements. Now look, there's a lot of things. I was reading this morning. Oh, some crazy headlines about PowerShell fear-mongering. Look, the bad guys use PowerShell. The bad guys love PowerShell. Let me be super clear about this. They do not use PowerShell to crack a system. Never, zero, never happened. They crack a system using something else. And once they crack it, they can run any code they want. They can run any code they want. They're already in. Once they're in, more and more of them are using PowerShell. Why? Because they have exquisite taste in technology. These are smart people. They choose great tools. No, I'm actually serious about this. PowerShell makes you incredibly productive. And it makes the bad guys productive as well as the good guys. Anyway, so in PowerShell, so it is not a security threat. It's just used by the bad guys as well as the good guys. In PowerShell version 5, huge investment in security. There's a great blog. If you just search PowerShell and Blue Team, you'll find it. Goes into lots of detailing. I will tell you, when you drill into the details, we have taken security to the next level. I mean, nobody's doing the stuff we're doing, okay? We have integrated dynamic languages into the anti-malware infrastructure of Windows, right? So the anti-malware has an option to take a look at dynamic code that gets generated and executed. That's for both PowerShell, VBScript, etc. We have ubiquitous transcripting, so anything anyone does gets transcripted. It's like Linux show script, or script, right? Everything gets logged, and then you can log that off to another machine. We have script block, deep script block logging. So anything that's done on the fly, we log it. So these bad guys that have payloads of payloads of payloads of payloads and do all sorts of obfuscation tricks, that all gets thrown away, and everything that they do is shown in the clear through logging. We have cryptographic messages, and we use those to protect the the PowerShell event log. So one of the things the bad guys do, they crack a machine and they look for information to go figure out how to crack the other machines. One of the primary targets is the event log. Now what you can do is you can encrypt your event log for PowerShell and then take it off box and then decrypt it off box. So when the bad guys look at the event log, they get nothing. That was done in such a way that in subsequent versions of Windows, we'll be able to do that for all the event logs on the system. Right now, it's just the PowerShell event log. And then we have the ability to run Windows in what's called a constrained mode with device guard, whitelisting of applications. When PowerShell detects that that is in force, it will go into what's called an auto-constrained mode, where it reduces the capabilities and basically cuts off some of the most powerful and potentially abused systems, techniques that get abused. Anyway, the log there goes into great detail. Key message, PowerShell version 5. You should install it and use it. It rocks. Now, packaging and deployment. In the past, anybody use MSI? MSI, almost a good idea. Almost, so close. Except there was this one thing called custom actions. And with that, it just turned into a disaster, okay? So we have a new thing called WSA, Windows Server Installer. It's based upon the client installer called AppX. It's a purely declarative, no custom actions, purely declarative way to do installation, and then we've taken the client model and then we've extended it with server semantics, things like NT services, perf counters, com objects, things like that. So now what that means is I can purely declare something, I can then install it offline, I can service it offline. This is just a fantastic approach. Now, one of the things I like least about Windows, turns out I like it least about Linux as well, is when I start a new system, I have what I call the scavenger hunt, right? Where are all the components of the stuff I need? Oh, I got to get this from there, and I got to get this from there, and this is in this repository, and here's the interface to that, and here's this in that repository. I got to do it. Oh my God, it's horrible. And so we wanted to solve that problem, wanted to solve the scavenger hunt problem. And we do so through something called PowerShell package management. So on the right here, there are lots of package sources, right? There's WordPresses, there's Node.js, there's NuGet galleries, Docker, container galleries, PowerShell galleries, etc. On the left, you got the poor user who just wants a simple view of this world. And what we've done is we defined a set of core interfaces for discovery, installation, and uninstallation, and inventory. And then we are writing providers that then map those abstractions to the different systems. This deals with protocol, how to install the package, how to register the contents, etc. And then in between those, it's not here on the diagram, is registering a source, okay? So NuGet, there is a public NuGet gallery, but what we actually encourage people to do, big corporations, is you want to create your own galleries, and you want to be able to find things that you trust and you put it into your galleries, right? So it's same protocol, same packaging, et cetera, but you have different sources. And then we have a whole trust model around this. Basically, we trust nothing. You tell us if you trust it. I encourage you to trust your stuff and not other people's stuff. And then there's an experience for that. So then the user gets this nice coherent model, right? Find a package. By name, find it wherever. Save the package, get it from that repository, save it in a file system. Often what you use then is to vet it and then put it into your repository, your safe repository for all your users. Install the package, get the package, uninstall the package. Pretty nice, simple model, okay? Turns out, as we talked about this in the Windows world, a bunch of Linux guys have come up and said, can we have that too? So we're looking at making this available as we port Linux, PowerShell to Linux as well. Configuration. We started with configuration a while ago with desired state configuration. As bizarre as it sounds, we just did not have a good architecture for configuring things on Windows. It was, again, one of those let 1,000 blossoms bloom. Well, at some level, the horse is already out of the pen on this one. But what we do is we now have a well-defined interface to these various subsystems. So whether you store your server configuration in SQL and you decide to put it in Active Directory and you decided to put it in the registry, let's have a common way to interface to those systems and then a common set of semantics. And we call that desired state configuration. So desired state configuration is really the key technology that allows us to do this cloud scale configuration management. A number of you are familiar with group policy, so let me just have the hard and crisp, clear conversation about group policy. Group policy is awesome and will continue for clients. It is not good semantics for servers. Desired state configuration is the configuration management for servers. Right now, there is a coverage disparity between all the things you can do in group policy and all the things you can do in configuration, desired state configuration. We will be addressing that, but make no confusion about it. Desired state configuration is the way we're doing configuration for servers. The nice thing about this is it's this nice mixture of declarative imperative. So if you take a look at Puppets start off as purely declarative, and they're rapidly as possible trying to add some imperative stuff. Chef, largely imperative, quickly as possible trying to add some declarative stuff. We're able to take a look at both those systems, and we come up with what we think is a very good balance between imperative and declarative from the get-go. It's largely declarative, but there are various points where you can have for loops and get expressions, get values from Active Directory or SQL, et cetera. And it's far more robust. At the end of the day, it's PowerShell scripting, but it's really just a set of conventions to make it more robust and simpler and more comprehensible. People are using this and being very successful with it. Now, desired state configuration is a platform technology. You can use this platform technology with scriptings to come up with your own solution, or you can buy a product, right? So Chef and Puppet, they're leveraging desired state configuration to manage Windows. OMS, that's our product, Operations Management Suite, we'll have an offering in that space as well next year. This goes down level. It's available on Windows Server 2008 R2 and later, and it is available on Linux. So again, we're trying to solve, look, Microsoft is fundamentally a different company than it was a few years ago. I don't know if you got the memo on this, right? Or you might have heard it in the press and wondered, what the heck's that? Or I wonder if that's just sort of press BS. And the answer is no. We got a new executive, Satya, and he's the real deal. I mean, I'm serious about it. He's the real deal. He told us very clearly, get out of your offices, go out and talk to your customers, find out what they need to be successful, and give it to them. He says, don't even worry about the money. Look, if you can make customers successful using our products, we have smart guys that can figure out how to monetize that. Don't worry about that. If you can't make them successful using our products, that's really hard to monetize. So go out there and make them successful. And when we did that, we found people wanted to be able to, yes, they love Windows, but they're using Linux a lot, and they wanted to be able to manage both and use both and have both be full first-class citizens. And so we've been doing that for a number of years now. As chief architect for Windows Server, guess what? A big chunk of my budget goes to providing great Linux support on Hyper-V, right? Great integration. Rusinovich doing the same thing in Azure. So it's not a press thing. There is product truth in this. Okay. Now, containers. We added container support in Windows Server 2016. We have two types of containers. The first is Windows Server containers. These are exactly isomorphic to a Linux container, okay? However, we have a new type of container, and these are called Hyper-V containers. Now, Hyper-V containers provide a much greater degree of isolation and security. So for instance, imagine you had a container from the KGB and a container from Hillary Clinton's campaign. You would not put those in a Linux container on the same machine. That would be a bad idea. Same thing with Windows Server containers, right? Not enough isolation. You could put those both in Hyper-V containers on the same machine. And the reason for that is those Hyper-V containers are provided protection through the VM interfaces, okay? So you can think of it almost as as a mixture between a container and a VM. It's a very, very, very light VM, but it gives you the isolation and security of a VM. So really quite nice. Now, also, I don't know if I talk about this. Let me go back. The team made a really bold decision, and I got to tell you, this was, again, one of those gut checks. Like, are we really doing this? Like, really? Oh my God, this is really a new Microsoft. We were down the path of developing our own management stack for our containers. And we were working with the Docker team to support the Docker API. At some point, the team said, we think we should get rid of our own management stack and only be able to manage things through Docker. I said, wait a second. What? So you're saying that we're going to have this important, critical new feature to Windows Server, and then the only way people are going to be able to use it and manage it is if they first download a third-party piece of software and install it on Windows Server? And they said, yeah, that's what we're talking about. I said, what are you talking about? Wait. And then we did the math. And the answer was there was a great ecosystem all built on the Docker APIs. And so we said, yeah, it was the right thing to do. So crazy bold decision, again, lots of gut check, like, oh my God, are we ready for this? And so that's what we did. Now the benefit is all the Docker tool ecosystem, they all work against Windows containers just naturally. Okay, so what we did was then we took PowerShell and we layered on top of Docker. So at LinuxCon this year, as I was showing PowerShell on Linux, we had a demo where we had a Linux machine and a Windows machine. And we took a PowerShell on Docker, did exactly the same commands, this managing Linux containers, this managing Windows containers, exactly the same commands. But then we went to the top, and because Docker's a REST API, we changed the configuration. And now this Linux box ran the Docker PowerShell commandlets to manage the containers on a Windows box, and the Windows box did the PowerShell commandlets to manage containers on a Linux box. My friends, the world we all wanted is upon us. It's a wonderful experience. Now, operational validation testing. This takes a little bit to get in focus. The point here is that sometimes things can be configured perfectly and just not work. Okay? So think about the case. A lot of configuration management tools deal with the configuration of a system. But imagine if a system is perfectly configured, but someone unplugged the Ethernet cord. It's configured properly and not operational. And so what we want to do is we want to be able to test the operation of a system. And so we had adopted, again, new Microsoft, we needed a unit test framework. And so I went out and found one in the community, an open source unit test framework called Pester. And I'm now shipping open source software in Windows, right? Craziness. So we got this and we said, hey, that Pester stuff, that's pretty good. We can extend that with a little piece of code, about 500 lines of PowerShell script, to have it also serve as an operational validation test framework. So this looks like your traditional kind of unit test framework. You describe a scenario, it's PowerShell, so you got some variable assignment. You describe a test, and then you run code and you assert things. Okay, get service minus SQL should be running. The SQL agent should be running, should be listening on this port, should be able to query information, right? So it's a PowerShell script. But then what you do is you then run this. You invoke operational validation, you give it that PowerShell script, it tells you about the scenario and then walks through each one of the tests, and when it's successful, it tells you how long it took, and when it's unsuccessful, it tells you it's unsuccessful. So think of the following. Anybody do Patch Tuesday? Yeah. Here's the question. Patch Tuesday, you just patched all your servers. When do you get to go home? No, seriously, when do you get to go home? How do you decide, right? What's that? After you test them all. How's that go? Yeah, in general, that's right. You want to test them all. But the reality is we test a couple and we wait by the phone and we pray. Sometimes we stick our fingers in our ear and go la la la. But in general, the day after, the night of Patch Tuesday, you go home and you're on pins and needles. That's a crappy world. That's a crappy world. So what we want to do is we want to create a better world, a world where you have operational validation testing for all the components of your system. So step number one, before you go patch everything, run the operational validation test, make sure everything's working before you change it. Then do Patch Tuesday, patch all your stuff, then run the tests again. And if all the tests run, happy days, you're in good shape, go home. If they don't, you have some issues. Now if you go home and it turns out there's an issue, here's the deal. It means you didn't have enough operational validation tests. Go add some more. But you know what? Now you've increased it. You've increased your coverage. With this model and this methodology, every day will be better than the day before and allows us to scientifically just advance and get better and better and better systematically. So I'm a big fan of operational validation testing. Now, I talk about the DevOpsification of Windows Server, and indeed, we put a lot of this attention and focus to Windows Server 2016. But as always with PowerShell, I'm always looking out for our customers that are on down-level operating systems. Now, most of these technologies I've been able to bring down level. Some of them I haven't. Can't recomponentize an operating system that's already shipped. Containers, that's core to the OS. That can't go down level. But these other technologies are available down level, as is PowerShell version 5, and then I believe in January, PowerShell version 5.1, which, by the way, if you haven't tried out 5.1, Jason Shirk, awesome engineer, just nailed the startup time. You know, the reality is that we had great startup time. When we went to auto loading of modules, we lost control of our startup time. Bad us. Jason Shirk did a heroic effort to regain those gains, and now PowerShell startup is very quick. In fact, the improvements in the PowerShell startup time is one of the things that allowed the client team to feel comfortable enough to now change the default shell. Going forward, the default shell for Windows will be PowerShell, not the DOS shell. So you're seeing lots of things kind of fear-mongering. DOS shell's dead. PowerShell killed Bill Gates. It's like, no, no, that's not it. It's still available. It's still there. It will be there forever for running legacy scripts or heritage scripts, like a heritage turkey. Anyway, so it'll be there for running your heritage scripts, but we're de-emphasizing it as an interactive experience. PowerShell will be the interactive experience going forward. So I mentioned to you that we did all this in order to be cloud competitive. And again, cloud competitive, you want to be small, fast, secure, and be optimized for a DevOps workflow. So let's see how we did. Resource utilization, we went from 26 default. This is server core. This is NanoServer. We went from 26 down to 21, almost 20% decrease in process counts. The number of megabytes required to boot the OS goes from 306 down to 108. 1/3 the number of megabytes to boot the OS. Crazy. So if you ever have a Hyper-V machine that needs to be rebooted and you need to start all those VMs again, it's your I/O that then causes the long delays. So you reduce the I/O, everything goes faster. Kernel memory in use goes from 140 down to 60. Less than a half the amount of kernel memory in use. Fantastic. But put your seatbelt on. Put your seatbelt on. Setup time goes from 300 seconds, 5 minutes, to 35 seconds. And I'll tell you, the first time you do that, you're like, what? What? Really? Just people like, something's wrong. What's wrong? The setup didn't work. Why do you say it? It just stopped as it started. Well, what do you mean it stopped? Well, it says it's done, but it can't be done. It was like 35 seconds. Like, well, is things working? Well, yeah, but something went wrong. Okay. Anyway, so huge improvements there. Disk footprint, and then the VHD size. Remember, I told you server into desktop makes me sad, SAD. It's because server into desktop is like 9 to 10 gigabytes. I mean, it's the full desktop. I mean, you get everything there, right? 9 to 10 gigabytes. Server core, about 6 gigabytes. NanoServer, 480 megabytes. Windows Server in 480 megabytes. Who would have ever believed it? And on a Gen 2 VM on a laptop, it'll reboot in like 2.5 seconds. 2.5 seconds. I was doing a talk. I was like, oh, something's wrong. Let me just reboot. And people are like, hey, what just happened there? I was like, well, I rebooted. And like, no. I said, yeah, want to see it again? Want to see it again? It's just like so crazy. Yeah, this is the real deal. You are going to like this NanoServer. It's hot. This has nothing to do with DevOps. I just can't say this enough. It just brings me so much joy. Let me just pause here for a second. Windows Server 2016 will support 24 terabytes of RAM. Listen to that. Windows Server 2016 will support 24 terabytes of RAM. It's crazy. 24 terabytes of RAM. Anybody got a 24 terabyte disk? Right. Nobody's got a 24 terabyte disk. You even have a 24 terabyte SAN? Yeah, many of you do. But this, you can have that in RAM. The VMs can have 12 terabytes each. And you might say, Jeffrey, what are you doing? You beat the competition just kicking sand in their face? Well, a little bit, yes. But no, the reason why we do this is there are certain workloads that really can use this. Things like SQL Hackathon, that's the in-memory database, they want all the RAM they can get. SAP HANA, all the RAM they can get. So you can really take advantage of this. And again, other stuff, awesome, right? Logical process support, 512, the VMs, 240, just fantastic stuff. So again, DevOps is about culture and processes. If you have great technology but you don't nail this, you're not going to do it right. Okay? But the reality is that tools and technologies can make things easy or hard, and that Windows Server 2016 was architected to make DevOps much, much, much easier. So I strongly encourage you to get on this. This is a rockin' operating system. It has some of the deepest architectural changes we've made. NanoServer is the deepest architectural change we've made to Windows Server since NT. It really is. It's sort of like a reboot of the franchise. Michael Green in the front row here has written an awesome document called the Release Pipeline. The URL's down here. And it talks about how you can take these techniques and tools and techniques and turn them into a Windows-based continuous deployment workflow, continuous integration, continuous deployment pipeline. Fantastic document. He's got some talks. He has some videos that'll just like, yes, that is the world I want. How do I get that? So I strongly encourage you to look up Michael Green and his great work, or talk to him. And with that, we have some time for Q&A, right? How are we doing on time?
We have about 6 minutes.
6 minutes. Oh, went a little bit longer. Questions? Oh, come on. Really? Yes, sir.
Go to the microphone, please. Thank you.
You know what? Just shout it out. I'll repeat it. It'll be faster.
Has anything been done for ACLs in 2016 for like just being able to run one subset of PowerShell commandlets?
Yeah, have we done anything for ACLs? No, actually, managing ACLs still sucks. PowerShell has some very simplistic commandlets to that. We've not improved on that. There's iCackles. iCackles remains the best way to manage ACLs.
Or even for users, like if we give developers the ability to just use read-only commandlets versus...
Okay, yeah. So in PowerShell version 5, we added this new thing called GIA. GIA is just enough admin. And what it is it allows you to create an environment through remoting. And basically, when someone connects in, you can have an ACL on it. And that person, in general, what we do is to say, make it an ACL that does not require admin privileges. And then they get access to PowerShell. But they get access to PowerShell now running as with elevated privileges. We create a virtual account with admin privileges for that user. And then you specify the commands that they can run, and only the commands they can run. And you can really lock this down. You can say, okay, well, you're supposed to do SQL administration. So look, I'm not letting you be admin on my machine, but you come in with your account. I will give you rights to restart the SQL, clean up the SQL databases, blah, blah, blah. And, oh, you're going to need stop process and start process. I can configure it so you can only start and stop the SQL processes and start and stop the SQL services. So we have fine-grained control over the environment that you provide someone. This is called just enough administration, kind of a key security technology. I'm using that extensively as I architect Azure Stack. Azure Stack is where we take the Azure services and allow you to run them on integrated systems in your data centers. And we are being super hardcore about security in that environment and using GIA sort of everywhere in it. Yes, sir.
Talk about the validation testing. Will you be shipping any tests that we can just use out of the box?
Will we be shipping any of the validation tests out of box? No, actually, I anticipate we're going to ship more of those things through the gallery. One of the things, honestly, we're struggling with is the when and why should we ship something with the OS versus something through a gallery. So, for instance, NanoServer. NanoServer, ships with all the components, but then you can also get those components from the cloud. And the intent there, we haven't connected the dots quite yet, but the intent there was, okay, so we shipped 2016 in September, and let's say you decide to deploy it in January, and you want to get IIS. Well, if you go and get it from the cloud, the intent was that the version you get from the cloud is fully patched. So when you deploy it and go, versus if you got it off the DVD, you deploy it and then you patch, right? So this trick of when and why do we ship it with the OS versus via the cloud is something we're struggling with, right? So at some point you say, it's obvious, put everything in the cloud, except we have guys in submarines that want to do things, and it turns out access to the cloud's a problem for them. So it's something we do struggle with. Yes, sir.
How useful is OpenSSH as a server to integrate it in the Service Control Manager and it boots up and runs?
How useful is OpenSSH on Windows? Yeah, it's one of the most asked for things amongst our customers. I can't tell you the amount of goodwill that we got by doing this. And so basically it comes back to this thing that I mentioned, Satya mentioned. You get out, go talk to your customers. And what we found is that most of our customers, I talked to a guy last night and he said, hey, this idea of sharding my IT by operating system, that's crap. That does not work, that's not efficient, I don't want to do that. Oh, did I get the question wrong?
Separating client from the client portion of OpenSSH must be very easy to use with PowerShell, but the server side of it, where you don't have a shell open.
Yeah, the server side of it, there the scenario is that people want to be able to use their Mac OS or their Linux box to then SSH into a Windows server and to be able to manage it. Yeah, so you'll be able to do that. Him and then you, and then you, and then I think we're done. 3 more.
Your NanoServer, is it implementation like Solaris Zones where you're borrowing heavily from the core operating system?
The question is NanoServer like the Solaris zones? And I don't know the implementation of zones, so I don't know the answer to that. Sorry. You, and then we're done.
More of a clarification question. So in a pure Windows environment, we're talking about being able to manage your systems remotely over OpenSSH. So we don't need to open 10,000 ports anymore?
Yeah, so that's correct. You'll be able to manage all your Windows servers using OpenSSH. That's correct. All your Unix servers, all your Windows servers. Again, just think it's really the story. And we're really close to making it true. Be able to use any client to manage any server using, in this case, using WinRM or OpenSSH. They're both great protocols. But the point is with OpenSSH, you already have some stuff. You don't have to add anything to that Linux box to be able to manage Windows. But again, any server to manage, any client to manage any server in any cloud or on-premise using any stack. That's what we're going to give you. It's crazy. Last question. I think it was you.
Is there any additional support you've done for legacy applications? Because that's the one thing we're all going to fight, is that it's going to be 5 years before we can run 2016 because an application requires something stupid or full admin rights.
Yeah, the question was, is there anything we're doing to help legacy applications run on Windows Server 2016? And the answer is, it's full server and server core are compatible. To run on NanoServer, it is a subset. There is no GUI, there is no local logon, you cannot RDP. So people really do have to refactor that code to get there. That is why we call it the focus point for version 1 is these born in the cloud applications, these new applications. Over time, what we'll do is we'll make everything be an optional component, and then the idea there is you'll say, okay, I got this existing application, I bring it in, I have to add a whole bunch of optional components. They'll analyze their code and find out, boy, if I just spend like this 2-month development spike, I can get rid of 6 gigabytes worth of dependencies and run really lean, and then they'll do that work. That's the intent. Thank you very much for your time. I appreciate it.